Alright guys, today we're going to graph corresponding terms. Here is your objective. Today I will graph data from a chart showing corresponding terms and a line plot. We're going to start with a warm-up. 5 swimmers complete in the 50-meter race. The finish time for each swimmer is shown below. Explain how the results of the race would change if the race used a clock that rounded to the nearest tenth. I see I need to round to the nearest tenth. Here are some rounding rules. First, find the place value that you'll be rounding to, which is the tenths. Next, look one place value to the right, which is the hundredths. Then, if the digit in the place is 5 or greater, you round up. If 4 or less, the digit stays the same, and all other digits roll to a 0. Alright, so let's look. First, I see a 4. I look to the right, I see a 2, so I know that 2 is less than 5, so my 4 is going to stay the same, and my rounded time is 23 and 40 hundredths, or 4 tenths. Next, I see a 1. I look to the right, I see an 8. So my 8 is going to make my 1 turn to a 2, and everything after that turns to a 0. So I have 23 and 2 tenths. I see a 2. I look to the right, I see a 1, so I know it's going to stay a 2, so I have 23 and 2 tenths. I have a 3. When I look to the right, I see a 5, which means my 3 is going to turn to a 4, so I have 23 and 4 tenths. I have a 2, and when I look to the right, I see a 4, so I know that I'm going to have to keep it a 2. So if the result would change if the clock was rounded to the nearest tenth, because what you see is that you have some ties then. You have this 23 and 4 tenths, 23 and 4 tenths, so you have 2 there, then you have a 3-way tie between 23 and 2 tenths. 3 swimmers would be tied for first place and 2 for second. Place value is very important, especially when it comes to a race. Alright, so what we're going to talk about, here's some vocabulary. Data. Data is a numerical information organized for analysis. Here you have a chart. Okay? It's organized for the ability to look at things and make sure that it makes sense and use those numbers towards something else. Corresponding terms are terms that are in a sequence pattern. So here I have 5 minutes is going to be 10 feet. Next I have 10 minutes is going to be 20 feet. And then I have 15 minutes, which is going to be 30 feet. Let's look here. The first thing you want to do is you want to recognize your axis and give the corresponding terms an axis. So you have your x-axis and you have your y-axis. When I look at my magazine subscription sold, the days is going to go on x and magazines is going to go on y. The next thing I want to do is I want to label my axis accordingly. So days, like I said, is the x, and y is the magazines. Then I'm going to see the corresponding terms as data sets. So I can just put parentheses and a comma in between those because I know my x and y are my coordinate pairs. So take a look at that. And then I want to give my values to the axis that makes sense. So my x's go right there down on the x-axis. I'm labeling my lines now. And there are my y's. So I want to count up to 10 because I know my highest number is 10. The fifth thing you're going to do is you're going to plot your points. So I'm going to plot 1, 3. I'm going to come over 1. I'm going to go up 3. And I have 1, 3. Next I have 2, 7. I run 2 and jump 3. I mean 7. My fault there. Next I have 3 and 8. So I run 3 and I jump 8. The last one is 4, 10. So I run 4 and I jump 10. Then I connect my line. It's as easy as that. Let's take a look at this problem. On her 80th birthday, Sarah's granny went for a trip in a hot air balloon. This table shows the schedule of the trip. So you see the times of 2:30, 3 o'clock, 3:30, 4 o'clock, 4:30. It moves in half-hour intervals. And the height above the ground, she goes 0, 150, 250, 350, 500, 250, 100, 0. I put my time as my x-axis, and I put my height as my y-axis. Then I need to go ahead and label my lines. So I label them with time this time around, and I label my height. And because I see that I go from 0 to 500, I decided to move up the lines by 50. So I went 50, 100, 150, 200, 250, 300, 350, 400, 450, 500. Because 500 is the max that I have to go to. Now I'm going to plot my points. I have 2:30 and I have 0. Then I have 3 o'clock, I'm at 150 feet. And then when I'm at 3:30, I'm at 250 feet. 4 o'clock, 350 feet. 4:30, 500 feet. 5 o'clock, 250 feet. 5:30, 100. And then at 6 o'clock, back at the ground. When I connect those dots, that is what my line plot looks like. Let's talk about some fast cars, Maserati speeds. I take my x and my y. My time is my x, my y is my speed. I label my seconds, 1, 2, 3, 4, and 5. And then I notice that there's a pattern. When I have 1 second, I have 15 miles per hour. At 2 seconds, I'm going 30 miles per hour. 3 seconds, 45. 4 seconds, 60. And 5 seconds, 75. So when I look at how far or how much faster I go from 1 second to the next, I see that I increase by 15. I found the pattern in what was happening. So that's how I use my terms to label my y-axis. I go 15, 30, 45, 60, 75, 90. I go up and up and up by 15. Then I go ahead and I label my points. So 1 second, I have 15 miles per hour, so on and so forth. So here I go, labeling. At 5 seconds, so I could then extend my line out and I could predict that at 9 seconds, I would be at 135 miles per hour. That would be super fast. All right, let's take a look at this. You guys have seen this many times. It's called a line plot. It's a diagram that shows frequency on a number line. So how many people like baseball as their favorite sport? 5. How many basketball? 8. Soccer? 7. Football? 5. And hockey? 1. I could then take this data and I could put it into a line chart. What I would like you to do is I want you guys to go onto iExcel and I want you to work in this order. Go to R1, S3, S10, and S11. Do all of those until you hit mastery. All right? Good luck.